Jot open. Good morning. My name is Jim Christophic. I'm a writer in the Southwest of the United States, and I'll be sitting down with you this morning, taking time in my schedule to eat breakfast with you and explain to you how to build a sustainable rain-catching solar-run structure out of the earth for very little money, let's say, in the big scheme of things, so that you can get on your land, get to know your land, and get on with life. This presentation is called the Hondo Hogan. Hogan is a Navajo word. I'm from a Navajo area. I grew up on the Navajo Nation, Navajo Reservation. And Hogan originally referred to your dwelling area. Now they use it to talk about traditional Navajo structures that people live in, do ceremonies in. So when you hear me say Hogan, that's what I'm talking about. So a little bit of background on me. I've been a writer for over 15 years. I've written 7 books, most of them on nonfiction subjects. This is my most recent book you see here, and it's titled House Gods, Sustainable Buildings and Renegade Builders. I moved to Taos, New Mexico, where there are many good sustainable builders who live there. I worked with them summer to summer for 5 years with no pay to learn from them what they had to teach. And so this book that you see here is the product of that time. And what I'm going to talk about now is the way I approached this problem of having a low-cost, effective, manageable, buildable, sustainable building on a piece of land, and I decided to use earth construction. So this is the first time I've recorded a PowerPoint. I'm going to get a laser pointer here, and I'm going to use this as I go through it. So we will begin here with the vision of the Hogan, because this is where we will end up. Why did I choose Adobe Cob for this Hogan? I want to go through those reasons with you right now, and maybe this will help you in your decision making. Because I worked with many materials. I worked with Earthship tires. I've probably pounded over 1,000 tires. I helped to build at least 3 Earthships that I can remember. Worked on many crews. I also helped build straw bale and lived in a straw bale structure, a little cabin, for about 8 years. I've worked around Pumice-Crete. I've made structures with Adobe brick, your standard 10 by 14 inch classic Adobe brick. And I've also built structures with compressed earth block, which is, the 6 by 12 blocks that you make with a Sinva ram. And I found that the Adobe Cob, what they sometimes call puddle adobe, was the best material. And here's why I chose it for this Hogan and why it might help you. Number one, it is inexpensive. It is mostly outside the money economy to use this method. I had materials delivered to my site. I had sand show up in a 9-ton load, and I bought straw bales, 2, 3, 4 at a time, whatever I could fit in the back of my Ford Ranger pickup. And that was it. What you see in front of you right now, that earth comes from the place you are looking at. Most of it came from my foundation trench that I dug, and a lot of it also came from the pit that I dug out to place my rain cistern, where that rain catchment pipe is leading to. So inexpensive. I didn't really start spending a lot of money for this structure. I spent very little money overall, under $4,000, about $3,400 on this structure.
But I spent very little money because I didn't start buying hardware store materials till I got to the roof line. So it's inexpensive, number one. Number two, Adobe Cob is always inexpensive. So this building is going to need to be maintained. There's the initial cost of building, but then there is the maintenance cost of keeping that building up. Buildings are a product and a continuation of human energy. The human must maintain the building for it to stay viable. So I needed to make sure that this building would live, and I put a natural plaster on the outside. As that natural plaster gets worn down, I'm literally going to take a shovel, I'm going to put it in a little trough, I'm going to mix up a new plaster with some water and put it right back on there. I will not need to go to the hardware store. So this building is going to keep me out of the lumber yard and keep me out of the hardware store and out of the money economy for quite a long time, if not the entire span of its life. So it stays inexpensive. You don't have to spend money on the kind of maintenance you're going to need to do for a building like this. Number three, it is simple. The simplicity, the simple beauty of the building is there. And what that created in me was an emotional reaction when I was working with this material. I built this structure with no electricity on site, done completely with the movements of my body. And that feeling, that emotional attachment I had to that method, it created something that was alive in me so that I could work for 10, 11 hours during the day using this material, and I would be fatigued but inspired to wake up the next morning and show up and continue working with this material. So that simplicity and that emotional reaction was very real for me, and it might be for you also. Number four, there is no advanced training that you really need to work with this substance, with Adobe Cob. You need some training, but I could teach someone how to do this method in about 15 minutes. And then the substance itself, the Adobe Cob, will teach that person the rest of what they need to know by just working with the material. But that is the purpose of this little presentation that I'm giving to you, is that this will help you not use so much time having to reinvent the mud, so to speak. The fifth reason this is an excellent material is that it preserves your body. I've worked with Adobe brick, and the Adobe brick that you can make instead of using Adobe Cob, it's the same substance, it's the same mix, only with one you're putting it into a form, and then you're popping the form and laying up the bricks on their side to cure for about 48 hours, and then you have to mortar them and mason them into a wall that will have to be straight, and it's a lot less forgiving if you do that. You can mess it up. It takes a lot longer than you think to mason a wall together, even when it's a wonderful substance like Adobe. I would much rather work with Adobe bricks than concrete block. It's much more forgiving, but it really taxes your body a lot. You have to pick up these 40-pound bricks that are 10 by 14 inches. You're more likely to tweak something. And because this method preserves your body, it really does preserve your sovereignty, what I call your sovereignty, what friends of mine have called your sovereignty, because nobody wants to just spend all their time building their dwelling. You want to have time to go up in the mountains and go on that river trip, or take your horse out into the pasture and enjoy life, to do whatever it is that brings you joy, in addition to having that self-reliant experience of building your own structure. And you really, it comes down to, imagine 3 circles. woven into each other like a shamrock or like a Venn diagram. And these three circles, they are the forces you are working with when you are building. And they are the forces of time, craftsmanship, and money. Those three things. You're trying to balance those three things of craft, how detailed and how exact can you be, the time it takes to do that, and the money it takes for the materials. A structure like this, the substance, the adobe mud, really leaves you a lot of room to play with those three rings of time, craft, and money. Number 6, I felt this structure honors the traditions of the indigenous people of the Southwest in a profound way beyond the adobe brick. What people may not know, when they think of a place like Pueblo Bonito at Chaco Canyon, it's such a big structure, it's UNESCO World Heritage Site, and they say that up to 800 to 1,000 people lived in Pueblo Bonito. But what you might not read about is that there are many great houses that were built in the Chama River Valley and in different spots along the, they call it the Ojo Caliente Creek, or the Rio Vallecitos Creek. And these great houses built by the same people of that culture of the Anasazi, they were building structures in that area that housed over 1,600 people, so almost double of the population of Pueblo Bonito. And you don't know about those structures because they were made with this method. They were made with adobe, not with stone, so they haven't lasted as long. But if those Anasazi people had had steel roofs that they could put on those adobe structures, they would be standing to this day. But they didn't have that advantage, and so their roofs caved, and eventually the adobe went back to the ground. But those walls that they were building were not made with brick. They were made with the Cob Adobe style, the weaving together of the straw and the material, weaving the walls together like meshing the fibers to create this wall, which is much more earthquake resistant, that is fireproof, that is monolithic. It is all one thing, and so it does not require a bond beam, and it will stay together in a much more cohesive way than a structure that's bricked together with adobe bricks. It's the same material that the Taos Pueblo is built from, which is not too far from this Hogan, the Taos Pueblo place I've been to many times. Many students of mine are from there. I have friends who I've taught who are also from there and who taught me a lot as well. And this structure was in keeping with that tradition that was put forward by the farmers of the Anasazi culture, whose ancestors live in the Southwest to this day, and also to the Hogans that many people, Navajo people, built, which also use the clay mud, what they call belej, or you could say the Cob Adobe. And in a way, it was a nice nod to my ancestors as well, who come from Northern Europe, Ireland, Northern United Kingdom, where this method also was used. The word cob, for example, is an old word from that region that means lump, like a lump of something. So you're using puddle adobe, lumps of this adobe structure to bring together, used by our ancestors for many centuries, millennia, and here is another structure that honors those traditions. So this is an example of that tradition and why I chose this material. And one other reason I should not leave out is the reason I chose this material is performance. I lived in a straw bale structure for 8 years. I lived in an adobe structure for 2 years. And I found this material to be superior overall. My dogs were the best critics. Where you are seeing here is Taos, New Mexico. It's southern Rockies. And in the winter, our days will be 28 degrees, 27 degrees, 32 degrees, sometimes in the 40s or 50s. At night, we have -1, -2, -18, -12. Very cold nights because we drain a lot of cold air from southern Colorado and the San Luis Valley. And this structure was designed to handle those kind of extreme elements. The straw bale that I lived in, during the winter, I would do a fire overnight, leave my dogs there during the day, and I would get home and it would be about 60 degrees, 62 degrees. After a night burning overnight log in the wood stove, maybe one log, maybe two, the straw bale would be anywhere between 56 degrees and 62 degrees in the morning. And this Hogan would be about the same. During the day, if I left a fire going for my dogs, it would be 60, 62 degrees when I got home. And overnight, even on a -12 degree night, it would be between 55 degrees and 60, 62 degrees. I could be fudging those numbers a little, but it's so you could say the straw bale outperformed it by maybe 2 to 5 degrees. However, in the summer, my dogs far preferred this Hogan. Those walls of the adobe cob are 12 inches thick. They are a foot thick, and they are beyond R value. R value measures the speed at which a substance retains heat. That is, that it allows cold to move through it and push heat out. That's R value. And adobe cob does not have R value, it has U value. And what it does is it holds temperature. So it holds heat, it holds cold. And in the summer, my straw bale that I lived in would be somewhere between 78 to 89 degrees in that building. And it was a south-facing roof, or I should say the main face of the building was south-facing. So it was a north-facing roof, which is, they say, how you're supposed to build solar gain houses. And that straw bale would be 88 degrees, sometimes 89 degrees. When I would come home, my dogs would be panting in that building. In this Hogan, with the floor not insulated, with good shade, good movement of the heat up that roof, and the walls holding the cold from overnight, it would never get above 74 degrees in that Hogan, even on a 92, 93, 96, 99 degree day, which we have in Taos, New Mexico. That Hogan, this Hogan you see, performed very well, and my dogs were never panting when I got home. So the dogs tell the story. It was, like I said, 74 degrees in there during the day. It often felt much cooler, though. And when you touch the wall, that wall was probably about 58, 60, or 62 degrees, the temperature of the previous night from before. So it allows way better, you should say, like time of transition, a flywheel of temperatures. So the performance was another factor. I'd mentioned the simplicity of this building method, and it is simple. In this method, you are going to use 4 substances. In this building method, you are also going to use 10 tools. Very simple. When building this structure, I used no electrical power. I had no electrical power on site. I did not run an electrical line down there. The only power tool I did use was an 18-volt drill that I charged with a really simple unit, solar unit that I built from a 50 watt panel and a 6 amp charge controller. So no power tools. And this is how it begins. This is a page from a notebook and another page from my notebook on it's a little moleskin notebook where I thought through many ideas and I decided on this idea. I wrote down all my numbers, basic rough dimensions, and I knew that this would be a structure where I could do all the things I need to do to live a comfortable life, where I can cook, I can bathe, I can exercise when the weather is bad outside. I can work out inside. I have room to play guitar. I have room to host at least 2 guests and also have my 2 dogs, at that time 3 dogs, living with me. And I can heat it, I can cool it, I can store food, I can maintain good hygiene. And this was the rough vision that I had. And this is what I put down. I used this just by hand with a pencil. So this is where it begins. They'll say very simply, ha de yahaira. This is you coming from the east. You coming with the thoughts. This is the very simple thoughts. That's a phrase from Navajo. So I then took those thoughts, rough thoughts, and sat down with a very simple architectural scaler, one that I bought at an education supply store. It was the second one I had bought because my first one I literally wore out all the numbers on it from continuous use over the years, designing different structures. So this was probably the 15th structure I designed with a scaling ruler. And it takes a lot of work to get to simplicity. I'm sure many other Stoic philosophers have said that better than I just did, but it's a simple fact that it takes a lot of work to get to simplicity. And this was my simplicity that I could see, where I had shelves for storage, I had cob fins on either side of the wood stove that would hold heat, or I would call them mass fins. I had good ventilation, I had good shelving, and I had ability to set up my kitchen area, all from a scaler. So the first step is to create your foundation. This is a very important step. It takes a lot of deliberation, and for myself, I wanted to simulate and get it down to the simplest way to do it. And so creating my foundation, that was done, I said no power tools. I did this by hand. I dug this by hand with a mattock. It took 3 days to do it. I did it in the early, well, I should say late autumn, August 20, like around Halloween, like August 28th, 29th. It was a warm October that year. And so, but it was cool. It was not too hot. And so I dug the foundation during that time and let the trench sit over winter. And so that was done by hand. And I used a rubble trench foundation, and I will go into the details for that now. Now, the way I had to do my foundation was beneficial because there was a grade to the land where I was going to build. So I did the rough measurement and I figured out that it's about a 1/12 grade, meaning for every 12 inches of horizontal movement, you have a 1-inch drop in the land. And so I knew that I was going to need to cut away some of the floor and put it in the lower part of the floor, the way you see illustrated here, to remove the earth and move it to the low side. They call that cut and fill. I learned this technique by reading a book about Adobe building, written by a New Mexico professor who had extensive building background, and they use this cut and fill technique to build roads as well. It's a very common civil engineering technique, cut and fill. The benefit of having a grade already in the hill, though, was that at the bottom of my trench I could begin my slope, which should be in the bottom of your trench. You need the water to run from a high spot to a low spot so it will get out of your foundation and move from the top side to the bottom side and just clear that trench and get out of there when it's draining water. You want it always moving away from your building. And having that center stake positioned in that way, that was very, very valuable to me. It's just a real simple, stake that you can buy, a contractor stake for like $10, and that was my center point and the place upon which the Hogan would ascend from earth to sky.
So once you establish where your building's going to be, you get a 6-inch datum to establish the plane of a grade beam. And you need to make a grade beam on top of this Hogan. Once again, you got to establish that slope at the bottom of the trench. And I just did this with stakes in a string. Just take a line level, make sure the string is level. The little bubble in the line level will tell you that. Gravity does not lie to water. Water always goes level according to gravity. Now what's happening in this trench, like I said, the trench is running down toward a dry well eventually. Okay, here's what goes in the trench. You need 2 inches of pea gravel. You need a 4-inch perforated drain pipe. Now when I built this, there was no perforated drain pipe available in New Mexico, in my region, because California had bought it all. So I just got regular drain pipe. This is the flexible, PVC black drain pipe with like the little ribs on it. It looks like a vacuum hose on a shop vac. And I just took my drill and drilled holes in it. Then you take 1-inch stone, you fill up the trench. I did this was probably about 20, well, this is the rest of the trench. So this trench is about 2.5 feet deep. So that would make it 30 inches deep. So the first 2 inches are pea gravel so that the drain pipe can rest on it. And then the other, 28 inches would be 1-inch stone. And you got to walk through it, you got to tamp it, pack it down, make sure it's solidly connected to this pipe, because when water gets in your foundation, which is going to be inevitable, it will wander down into this drain of stone. It's sometimes called a French drain. No, that is not because the French invented it. It's because a man named Thomas French, who was an American farmer, he came up with this idea of how to drain land using stone trenches and gravity. And then on top of that, you want a 6-inch concrete grade beam. All of this is so that water can flow down into this pipe uninterrupted and run into a dry well that you will build from an old 5-gallon bucket with holes drilled in the bottom filled with rocks with a piece of plywood over top, and you bury that under the earth. That way all the water runs into there and it can slowly leach back into the soil. Because what you're trying to establish is you're trying to establish that 6-inch grade beam that rises up off the ground, and then you want about 12 inches of stone wall on top of that. That's sometimes called a plinth. It's to distance the cob earth from the ground, the snow, the rain, to keep it safe, keep it dry, and so it will last for over 500-600 years. That's how long a cob wall can last, if not longer. There are structures, we know this by the way, because there are cob structures that were built in the 1400s and 1500s that are still standing. So you established your datums. You've got all that set up. One way I did this was just going, okay, I want this string to tap this center stake at 9 inches. Then it should be 9 inches from the deck here. It should be 9 inches from the deck here. And then I have my floor. You take a 10-inch steel tamper. That means it has 10 inches on the bottom here, 10 inch by 10 inch, and you walk in a circle and you drum the earth until it is ringing like it's made of steel itself, like it should be very, very solid, very hard, so that the earth is compacted and it's not going to move around on you. All right, so you've got that set up. Once you have this set up, then you can start bringing in your stone. Okay, so this is what you want first. Now, after I had established the floor of this Hogan, my trench was about 12 inches wide on the south, okay, because that's how thick my wall was going to be. It's going to be 12 inches thick in the wall. And then my trench on the north side was 21 inches wide. The reason for that is that I knew I was going to add an extra 9 inches to the north, and you'll see why I did that in a moment. And all of these are stones that I knew I was going to put in my stone wall, and you kind of gather them around the area out of the way of your feet, but you kind of are placing them so that you know where they're going to be. Like I said, once you start filling the trench, you're going to get that marked stick, 2 inches marked on the stick, stick it in the pea gravel. If it matches up, you know you're at 2 inches. It's just really easy. Otherwise, you're going to be sticking your measuring stick down in there. It doesn't make any sense. You're going to break up your measuring tape. You know, it's just dumb. So just mark the stick with your measuring tape and then use the stick. And then after you've got the pea gravel down, you're going to put in that 4-inch pipe that's perforated. So it's going to lay in the trench. Here's the floor of the Hogan. It's been established now. The flow of water is going to go in there. Now what you have to do is buy a coupling. This is 4-inch pipe. This coupling is available at any hardware store, as is the pipe. You just figure out how many feet you need, and you're going to join it to the coupling with PVC, cement. They call it dope. You know, you're going to have a primer. It's the purple stuff, right? You have a purple primer, and then you have the clear glue that basically dissolves the PVC and makes it rejoin as one thing. And it's going to run into this dry well that's made, a dry well that's made out of a bucket, a 5-inch, just a 5-gallon bucket with rocks in the middle in it, and then you put a lid on top. I used a piece of plywood with rocks on top, and I also encased it in 4 millimeter plastic. Yeah. And so when you're done, this is what it looks like. Okay. So I've got my trench dug, got my stakes placed. Here's my tamper, and all this is getting tamped all the way up to the top of the floor. And there it is, and that's what it looks like when it's done. So all that got tamped up, all that is below the surface now. Hopefully never to be removed. Okay, now when you're setting up for your concrete grade beam, you want to set up your datums for 6 inches, because you know the top of the grade beam is going to be floating over this trench at 6 inches. This way it ties the entire foundation together. It creates a good pressure. It's like a bond beam for the foundation, hence grade beam. And also it gives you more height, so your stones have to make up less height as you go. So now we're going to create the grade beam. So this is what you're going to do to lay it out. Now this is annoying because rebar, as you may know, is straight. And so what you have to do is get a rebar bender, or you can use a board, you can use a piece of pipe and bend the rebar that way. But it takes some finessing to kind of figure out what line you're going to go. And I wasn't being very precise here. This is just rebar that's meant to reinforce a little 6-inch grade beam. You know, this is all a circle, and it's very annoying. Now, some people, to bypass this problem, if I did this again, I would do this. I would not use rebar again. I would use barbed wire probably, because it'd be much more flexible, or just, you know, standard fencing wire. You could do that too. Some people recommend that, but I went with rebar because I'd worked with it before. I put in rebar on the foundation of this little greenhouse that I built. It's a CEB, compressed earth block greenhouse. And I felt it was a good material, even though it was annoying. And then you have to do double ties where you take tie wire and you want to overlap these little gaps between the pieces of rebar and tie them together, reinforce them, use rocks to lift the rebar up. Do not go and buy those chairs. You don't have to do that. Just use a rock. It'll be fine. It'll suspend the rebar up into the air enough where it's in the center of your grade beam. We're talking 3 inches here, to be up in the grade beam. So it's not a problem. So then what you're going to do is build a form. Now what I did, because it's circular, I went and bought masonite. You buy masonite in sheets like plywood, like 4x8 pieces of plywood. So I had the guys at the hardware store cut them so that they were the appropriate height. I think I went with 12 inches as I recall. Yeah, 12 inches. I knew my grade beam was only going to go up halfway, so that was easy. So I could go, oh yeah, there's my 6 inches in the middle of my 12. And then every 18 inches, 18-inch gap, I would drill 2 holes. Bop, bop, then bop, bop. The reason for that is so I could put in reinforcement wire. So I've got my rebar laying down here. My stones are under my rebar. I lay the masonite forms one on each side. When the wire goes through like this, I bring the wire over and I bring it back through and I have it set up and I tie it together so it makes a cross and holds. Now, to get started though, you want to make sure you mushroom head your tie wire. And you do that by making this little shape. And that will catch against this hole and you run that through. Okay, so once you get started with these materials, they'll talk to you, that you'll figure it out. It's really not that complicated. It might look complicated looking at it for the first time, but it's not. The wire will start holding the masonite. The point is you want the masonite set up so it is the exact width, which for me it was 12 inches. And you've got the depth. See, I took my my wire and made it 6 inches tall exactly, so I knew, where my grade beam was going to be the whole time. So that was very helpful. And you can kind of see that here. There's my extra 9 inches there, and you'll see why. So like I said, you've got to know your doors and your windows. I literally had sketched this out on the back of a piece of paper with my scaling ruler, so that I knew this is exactly how wide they're going to be. On the inside, this is exactly how long I need my bottom board to be that I'm attaching to the concrete. I'm giving myself little notes of what I want to do with these doors and windows. I need to know how big my lintel is. I need to have a 1-inch gap between the top of my window buck. This is going to be my south window. So I need a 1-inch gap between the top of my window buck and my 60-inch lintel. So you need to have all of these drawn out and figured out before you do your inserting. Right? That's very important. So after the concrete grade beam was done, I needed to create my stone stem wall. A stem wall just means you're lifting the wall up in the air so that the earth, the cob, the adobe, is not going to be harmed by the splashback of rain or ice or snow. Because of course the weakness of adobe, of cob, is when it gets wet. It can tolerate moisture, but it can't tolerate incredible amounts of moisture, and the clay will begin to be drawn by gravity as well as silt, and it will begin to dissolve. So there you go. There's my grade beam done. Now a note on this, I could have done a better job getting air out of the concrete. I think if I'd done like 2 or 3 more passes with a piece of rebar, I could have had the aggregate sink much better. But that just didn't happen. So, oh well, live with it. It's fine. But if I did this again, I would do that. Now you might be asking, hey, you built this down in a spot where there's really no accessible road. How'd you get a concrete truck down there to do that concrete? Well, I didn't. I did it all with a wheelbarrow. A dear friend of mine was coming through town, coincidentally, synchronistically at that same time, and I had him help me. So we did all that concrete. It took about 7 hours to do that. And so don't underestimate how long it takes to mix and dump concrete. It takes a while, but the concrete pretty much lasts forever. It gets harder and harder and more resilient as it goes. So if any of you are professional concrete people, you're probably looking at this like, oh man, he could have got more of that air out of there. Well, you're right. You're right. Good observation. So here I'm using your standard mortar mix from a bag of, Portland to match my stones. Now the rule on stones and laying stones, and by the way, all these stones I had pulled out of a wreckage, just like a demolition pile. Some guy had torn down an old adobe house in Taos from the 1930s. And all of these stones were part of the foundation of that house. So I have a Ford Ranger, 1996 Ford Ranger. It's got 300,000 miles on it. Love that truck. And I just went to the pile every day and put stones in there, 80 at a time, and took them back to my spot and dropped them off. And so I slowly collected those stones with a small truck. I did not have them delivered. They are not from that site. There are other stones I used as well that came from a neighbor of mine who was a professional excavator. So if you need to find stones, look for excavators. Excavators usually have extra piles of river rock, extra rock just laying around, and you can usually be polite. They understand if you're going to do a building like this, a small building, and that will be very helpful. And I don't think I said this at the top of the video, but I did this structure as an outbuilding by code. So I matched it up to the size of traditional Navajo hogans, which are typically between 10 and 15 feet wide down the center in terms of their diameter, right? If you go and look at hogans from the 1900s that are still standing, which there are some that are, and I went and found them, they are usually 12 to 15 feet wide. So I did mine at 12. So this is 12 feet from here to here, which puts it under the square footage of requiring a building permit in my county. That will be different from where you live, depending. But it's also possible to get a permit using the details in these these plans on these slides. Just talk to an architect. So once I started my stem wall here, you have a basic setup of the Hogan, the structure. So I've got my pea gravel. I ended up doing 18 inches. Okay, so strike that from the previous slide. I did do 18 inches knowing I was going to have a 12-inch wide wall here. That was smart of me. That's good. I had 28 inches of 1-inch stone, 6-inch concrete grade beam, a 12-inch stone stem wall. That is what you start with. 12 inches wide because my walls were going to be a foot wide. That's pretty wide. And that's good because you want that thick adobe to absorb heat and to hold heat. And we can get into the details of that, of why it is. The adobe wall is beyond the R value. The R value does not apply to adobe walls, and I'll explain why that is. And so, like I said, I left 9 inches of foundation left for the thermal wall here, right? And I had 30 inches here. So that is what has to exist first before you begin the creation of adobe or Cob. And I would say this creation right here, from the bottom of this, the trench going up stem wall, grade beam, stem wall, all that took about 2 weeks for me, about 2 weeks. So now I need to create door and window bucks. So, like I said, I got to know exactly how my door buck's going to look, how much is going to hang out here, how tall is it going to be. Now you might be thinking, 56 inches tall, what are you, a midget? I'm 6'3", I'm about 200 pounds. I've done jiu-jitsu for 15 years. I'm a decently athletic guy. I don't mind that it's 56 inches tall because that's how tall all the doors were in every Hogan I visited. I'm sure that's true for 2 reasons. Number 1, it creates a smaller hole for less heat loss in the building. And number 2, it creates an aesthetic experience, in my opinion. When you walk through a door that's only 56 inches tall, you duck down and then you stand up and you're in a whole other reality. And it's a very beautiful experience. So if you don't like 56-inch tall doors, build your door how you want, adjust your wall how you want, not a big deal. I just did it that way because I was trying to connect with those traditions. Okay. So when you're seating this door buck, you're going to do this little trick with a different sized bits where you basically, your J-bolts are down here where they're going to join the concrete, right? This is coming up out of the concrete. You're going to drill a hole down into that treated lumber, right? You've got that treated board that's going to be your bottom board so that the concrete, which is a phase liquid and will rot the wood, it's not going to be able to get through that treated board and rot it. So you're going to put that hole there, you're going to set this on top of that J-bolt, and then there's a nut that you're going to put on top of that. Now, if you didn't do this trick, it would just be sitting level with this and you'd be hitting it with your foot and it would be very annoying. So you can use a paddle bit. I don't use paddle bits. I tend to use just bigger bits, like a 3/4 inch. I think that's what I used for this. And I needed it for other things too, so I spent the money and bought the 3/4 inch bit. And you drill down just slightly into the board so that the nut will sit level with this board, and then you put the nut down in that hole. This is very exaggerated. It looks much more clean than this in real life, but I'm trying to communicate the principle to you. So you want to seat your nuts down into the board. Which nuts? These nuts. There they are. Okay. Now, this is a very important detail. When you set up your door bucks, and there you've got my holes drilled there to accept the J-bolts. I've got some shims in there to correct, because this is very common. A door is never level. You've got to use little shims. You go buy a pack of shims at the hardware store. They're not expensive. Then you need to brace everything. So I've got my diagonal braces here. This is not going to be magically level when you set this up. It doesn't work like that. So you've got to adjust it, you've got to tune it. You set your brace boards here, you attach them to stakes with the screws. I did that here too, bum and bum, there you go. This is my south window. That is to the north, this is to the south. This is my door. They are 2x12 boards, rough sawn, because I know my wall is going to be 12 inches thick. So that's a nice little guide for you as well while you are building. These were all hand cut. Like I said, I did not use any power tools except for my drill, and I literally cut them on these straw bales back here as my sawhorse. You don't need fancy stuff. All right, and I walked them over there and set them up. So this is looking now through the doorway, right? So this is my south window that we just saw. This is the entrance from the east. And I have all these stones that I'm going to be continuing to use set up around near my stone stem wall. Now, with those set up, I'm going to begin creating mud with the 4 substances and the 10 tools. This is what I'm trying to achieve. My pea gravel, my 1-inch stone, my 6-inch grade beam, my stone stem wall, and then the mud adobe wall going up. So it's a spiritual structure. Here are the 4 substances. You're going to use 5-gallon buckets. One will be for water. The other one will be for sand. I had about 9 tons of sand delivered to my site. Now you could go down in a wash, find a sandy wash, and load all that stuff up in your truck and drive it back and call that sustainable. I think it's much easier for a big friggin' truck to just deliver it one time instead of you having to make little runs with your little truck over and over and over again. That's my opinion. You can do it how you want. And then you have a bucket dedicated to the clay earth. Now there are different ways to determine whether you have enough clay. I knew that my earth there was about 83% sand, 6% silt, 11% clay, more than enough. I did what's sometimes called the ribbon test. It's really easy. You just take your dirt where you're going to live, your site earth, and you put some dirt in your hand and spit in it over and over until you have a mud, and then you roll that up like you're rolling a cigarette or making a clay snake. They call it a ribbon, like a ribbon test. And then once you have that little snake rolled, you hold it out in the air with your index finger and your thumb. And if it will hold together and maintain a solid horizontal plane and not crink or flatten or pull away or droop, you know you have enough clay. I also used a mixing trough. Buy those for $10 at Ace Hardware. They're for like concrete mixing. They're sometimes called mason trough. But if you look at the actual product, it's called a mixing trough. And then you need straw. Straw bales are usually $8 a bale. As of this recording, they might go up, they might go down. But your basic straw from a ranch feed store. Those are the 4 substances. 1, 2, 3, 4. And then you're mixing them in a trough. And so we are here now with the 10 tools. You have your mattock. I use standard mattock with the flat edge and a pick on the other side, but you could use a Pulaski as well. You have your standard shovel, good digging shovel, 5-gallon bucket. You'll need that for transporting sand and clay, and also the mixing trough where you will mix the mud and get everything set up. Then you have your 3-foot 2x4 board. And what that's for is for smoothing out the skin of the inner wall and outer wall while you're building it up. You have your 4-foot level to always be checking to make sure the wall is plumb, that it is in a straight accord with gravity. Gravity's not going to push it over, but it's going to drive it straight down into the earth, into its foundation, which will more than hold it in place. So that is a stable building when it's plumb. Called plumb because it comes from the Roman word plumba, which means lead, and it's called that because they would attach a lead weight to a string, and that lead weight would hold the string by gravity exactly straight. So hence plumb, which they still use with a plumb bob today. Those are all tools you will buy at the hardware store. The other tools, you have your cobber's thumb. You just make that on site out of a sturdy, easy to pick up, nice, thick stick. I used a piece of juniper, a juniper branch, and it had a very good grip handle on it, and it had a curve to it, which made a very nice fulcrum, a good pressure point, and I could push the cob with it. And the cobber's thumb, what you are doing is you are driving. Imagine the surface of the cob like the surface of the ocean, and you are driving at a kind of a southwest angle, a down inward angle, like a diver diving at an angle into that water. You are pushing and threading and sewing the straw of the mud into the straw of the previous layers, so they are more monolithic. They're all one thing. So the cobber's thumb is very helpful, very important. Then you have your wooden spacer. I used a piece of scrap lumber. I think it was a 1x1, really simple, and I cut it exactly 12 inches so that that became my spacer. I knew when I put that on top of my wall, it was exactly 12 inches thick. It wouldn't go beyond, it wouldn't go in between. And I knew that that in many ways was acting like a plumb. It was acting like something that would keep my wall plumb, because I knew, hey, if everything's 12 inches exactly off the center, it's centered. It's not going to sway or deviate from my original line of plumb, which the human eye cannot detect, by the way. You really need to have those little air bubbles in that level talking to you and telling you where gravity is. And then you have your wooden knife. The wooden knife, I just, shaved an angle or two off of a stick, off of a piece of scrap lumber, and that is very helpful for driving cob in and around little doorways and around window frames and doing little detail work. Another tool that is not on here, I wouldn't call it the essential of the 10 tools, but it was very helpful, was a Bondo knife when you're talking about inner plaster. It's very similar to a wooden knife, but it gets into even more detail. We'll get into that later. The 10th tool is the body. Treat your body well, stretch before and after you work. I did that. It was very helpful. And a word on the body. Now, the way people make cob in many circles, I've seen a lot of videos, I've read about it in books about cob making, which is that you use tarps to make the adobe cob. I've seen people doing this. I have done this also as an experiment to see, okay, let's see if this method works. I see images and videos of people taking their shoes off and dancing the cob together and using their feet to drive the cob and mix it. I did not do that for many reasons. Number one, I was not going to leave my body vulnerable to the many goat heads, stickers, cactus spines that are all over any job site in the Southwest. I did not clear my job site. I didn't have a backhoe come in and rip everything out. I was preserving as many sagebrush and as many little piñons trees as I could. And so I did not dispense with my shoes and dance the cob together. I did not do that, and I used the mixing trough. And that mixing trough technique is faster and more efficient and uses far less water than the method where you're using a tarp. And I'll get into the detail of that. And so what I did instead was I just bought a pair of shoes I knew were going to be my mud shoes for $40 from Big Five Sporting Goods or Walmart or wherever. And I used those to push on the cob and build up the adobe using those shoes. And I will now get into what you're going to be doing with that mixing trough. So what you're seeing here is where you want to be when you're done mixing adobe, and it's really simple. The way I did it and the way you could do it, which works very well, is I took one of the 5-gallon buckets and I walked to where I had loosened up the dirt with a mattock. I shoveled 6 shovelfuls of clay earth into my bucket. I walked the bucket over, I dump it in the mixing trough. Then I would put my water on the clay earth, because you want to give the earth time to absorb the clay that is the earth. The clay in the earth, you want to give it as much time as you can to absorb the water. And you'll figure out what the best amount of water is to use. Like I knew, okay, I'm going to use 6 shovelfuls of earth. I'm going to put it in the mixing trough, and I'm going to use 3 cans of water. And I had these in just a little can of beans that you would buy in the grocery store. I just saved the can, and that became my water gauge. And I knew 1, 2, 3. Then I would pick up that 5-gallon bucket. I'd walk up the hill to where my sand pile was. I shovel 6 shovelfuls of sand into that bucket, walk it back down, pour it on top of the earth that was in the mixing trough that had already absorbed that water. I would put 2 more cans of water on top, and then I would go to work with my shovel. And what I'm doing with my shovel is I'm cutting little slices. I hold my shovel like a canoe paddle, like you're going to paddle on a canoe, your arms out, using your hips and your legs, and you make a series of slices down one row, slowly chopping the clay and the sand together, and then make a series of slices down the other row, slowly chopping and cutting the materials together, allowing the water to do a lot of the work, and you go back and forth up and down the row, either side, and this is what you will end up with. This is how you know the mix is good, that I have that configuration. I can take my shovel and go down the center like that, and it will leave a track behind it, and it will hold that pattern. So I've got the right amount of water in there, my sand and my clay is mixed correctly, it is all part of itself, and now it is awaiting the straw. So what I will then do with the straw is I take straw, a handful of straw and another handful of straw, and I stab them into each other in my hands. Imagine, you had a knife in each hand and you stab the knives into each other. So you're stabbing that straw into each other, and I shred it back and forth, rub it back and forth into itself, and it will shred itself apart and break itself up into little particles just by the friction of the grass, of the cellulose ripping into itself. Many people do this in Mexico. A guy from Mexico showed me how to do this. It worked very well. And then I push the straw into that mud adobe mix with my feet. So you're driving down with your body weight, pushing it lightly. I would just sort of bounce the straw down into the mud mix and let the viscosity of the mud grab the straw and pull it down. Then I would do it again, and I would push it down. Then I would do it again, and I would push it down. Nice, light, careful, just kind of tapping my foot, bouncing it on the surface. And eventually it holds a lot of straw until the point where the straw is like a mat inside that mixing trough. Then I would take my hands to the far right-hand side that you see on this illustration, and I would lift up the mat of straw and roll it back into itself like I'm rolling up a mat or a rug, like I'm rolling up a jelly roll back into itself. And then I would put more straw, shred that on top, and I would push it down with my feet into itself. And eventually you'll get the feel for how that comes together to work and make a very nice connecting, gripping mud mix. And what you'll see in the next slide is how that mud mix should look and how it should work. What you're seeing in this slide is the simple pattern of shovel marks I would make. One going down one row, one going down the other row, nice easy slices, cutting the sand and the clay earth together. And so there you have it. This right here is what you are looking for. When your straw and your mud come together, they will make that shape. You should be able to make that shape with your hands and just pick it up and hold it in your forefinger and your thumb, and it should be able to stay there in midair and hold that shape and not move. And this is one of the advantages of Cob Adobe that is different from brick adobe. When you're making the bricks, they are being joined together by masonry. That masonry takes a lot longer and requires much more precision than you might think until you've actually done that work. That greenhouse you see to the right in this slide I built that from compressed earth block, which is very similar to Adobe. You can look that up on some other video somewhere, what compressed earth block is. But I found it to be very slow and laborious to be mortaring block and having to be so precise and cutting the block and getting it right and blah, blah, blah. This was so much simpler, so much easier. And the beauty of this monolithic structure is that you do not have to create a bond beam when you are building this. It is much more elegant and much more sophisticated in its composition. You are in many ways weaving the wall together. You're not mortaring it on edges with a mud mix you have to make separate and hope that your Adobe bricks cured correctly or didn't get damaged, and then you have to pick them up and throw them on the wall and then more. This, you are making the wall as you go, and you are weaving the structure together. You are sculpting the wall, and try doing both of them. You will see that this has that quality to it, this style of Adobe construction. And it is, like I said, monolithic. It is all one thing. It is much stronger, much more earthquake resistant, and does not require a bond beam at the top of the wall. And if you've ever had to haul 5-gallon buckets of concrete up a scaffold to build a bond beam, you will know how much labor that is and how intense that is. In a word on labor, keep in mind that the Anasazi or Anasazi ancestral Puebloans, they made structures this way. They used freeform puddle adobe, Taos Pueblo, which I visited many times. I have many friends who live there. They build their Pueblo, which has been there for time immemorial, out of this method. It's built with no foundation. There have certainly been earthquakes over the centuries. It has been there. It has not fallen over. And it wasn't until the Spanish came and brought that technology of the brick that was incorporated. And the first builders of those adobe bricks in the region were slaves. So there's a kind of a connection between slave labor and the use of adobe bricks, which is why they really do tax your body. I felt a bit like a slave when I was building adobe brick, whereas I did not feel that way building with this method. And so this was the basic setup. Each batch was made of 6 shovels of earth, 6 shovels of sand, and the straw. And each batch was able to cover about 2 feet of a 4-inch tall wall section. So this is how the wall comes together. So I've got my 12 inches here. I've got my mud wall. And what I do, and this works very well, is I lay in my spacer as I'm building the wall. When I do that, I lay the spacer, I push it down into the wall so it makes these little indents. This is very helpful for getting the cob, the mud, to bond back into itself on your second run through it. So this is my first run. I'm going to come back and I got to keep laying the mud on top of itself. So in a way, I'm laying down these little railroad tracks, almost like ridges on a Lego block. I have never seen this in a book. I kind of came up with this on the job. Then you do want your indents from your cobber's thumb. You're going to drive that cobber's thumb, which is like a long stick that's very sturdy, and you're going to drive it at this angle, at an inward angle. You're not pushing out, you're pushing in to drive the straw down into the mud and make it connect with the previous layer of mud that was in there. And you're laying your spacer. And I did this probably every 18 inches, every foot. And so what it ended up doing was making a surface that was really, really toothy, as they say, for the mud to grab onto. Because like I said, if you treat it like an invertebrate animal that wants to get down to nooks and crannies and secure itself, that is very helpful for your imagination as you are creating this. And so this is what you end up with. You end up with a wall that retains this shape where you have the spacer pushing down, making a track every 24 inches, about every 2 feet. And you have the indents from the cobbler's thumb as you are driving the material, driving the straw down into itself, and making a very good sticky surface to then place your next layer of mud into. And so in real life, that's what it looks like. You end up with this textured surface top done very intentionally so that the cob, when I put the next layer of mud on, it's going to dig down into these holes, and it's going to dig down into this track here and really grab that wall and be very secure. And that's what you want, because you can build this structure wrong. It can happen. But if you do it the right way, all is well. So what you end up doing is, so maybe 2 days before I did this layer, the next day I did this layer, and now I'm doing this layer here. Maybe I did that, actually, let's say I did this 6 days ago, I did this 4 days ago, I did this 2 days ago, and now I'm coming back to it, and it's solid. And it will trick you. It's weird. You've got this mud that you've laid down and is soft like jello or pudding, but you come back 2 days later and try to punch it, and it will break every bone in your hand, because it is solid. It's compressed together by the force of gravity working through the water in the mud, and then the water evaporates to a degree. So when you come back to lay the mud onto the previous section, you've got to wet that previous layer of mud to create that bond. So I just took a coffee can, I would just splash water over it. The water would go down into these little divots and into the little ridges, and it made it very helpful. So this, I've never read this in a book. This was intuitive. I think it works very well. People will disagree. Maybe you'll say something in the comments. Whatever works. But I showed you the initial picture. I'm going to show you how I got there. This is how I got there. So like I said, in this process, what you also want to do is you want to lay down like a slime trail over the previous surface. So here was my previous surface. I'm laying down the mud so it really gets down in there and it just grabs everything down there. Then I'll add my larger cobs of mud. So you don't just take big cobs and slam them on there when you're taking them out of the mixing trough. You want to create like a base slime layer that then you put the larger cobs on, and you're driving them in with the cobbler's thumb, just like that, so that what you've laid down is not just one separate wad of mud, but they're joining together. The straw is joining them together. And you're only adding cob about as tall as your hand. You should really only be doing about 4 inches at a time. And you might be saying, well, that's pretty slow. With Adobe, you can go straight up. Slow down. With Adobe, you have to make the bricks. You have to cure them. You have to store them. They have to sit there. They have to cure for at least 48 hours. And then you have to mortar them together, which I've done many times. If you've never done that, you'll see how much time that takes to get it right with that mud mortar. With this, you're not mortaring at all, and you're not storing it anywhere. You're storing it in the wall as you go. So at best, you could say they're about the same amount of time. But if you wanted to do better, you could say this might be faster, depending. Also, if it rains, this wall is not going to get destroyed. It's going to absorb that rain, and it's going to hold, which is why this technology comes from Northern Europe and from areas of the Middle East that do get deluged with rain. It's not from the Iberian Peninsula. It's from, which is much drier, by the way, but this is the kind of earth construction that comes from a place where you have wind-blown moisture all the time. And like I said, those buildings that are standing there in Wales and Ireland and Northern England, they've been there for about 500, 600 years. So keep that in mind. So as the mud starts driving up against your door bucks and your window bucks, you're going to do a thing called porcupining. And a lot of this information on porcupining is available in a great book. It's called The Hand Sculpted House by Ianto Evans, Linda Smiley, and Michael G. Smith. It's an absolutely important book to read before you do anything along these lines. Read that book. It's very enjoyable. It's a poetic book. It's wonderful. And this porcupining is talked about in there. I found it worked very well. And you're basically just going to your Habitat for Humanity restore, get the crappiest nails you can find. The more bent and crappy and rusty they are, the better. This is the time to use those recycled nails. So there's a lot of recycled materials that went into this Hogan, and these were one of them for sure. And so, like I said, the mud is like an invertebrate animal. It's trying to grab these porcupine nails, and that's going to help your mud and your wood become one thing. They're different materials. They will not naturally bond with each other, but the little porcupine nails will allow that interface, that bonding. Now, a little detail on that: when you are building up your door, it will be fine. The mud will grab this, it will not walk away, everything's great. But when you get to the corners, if you try to go fast and slam the mud up there and just stick it right up there and everything will be great, what's going to happen is, remember, the mud is shrinking because the water is part of the volume of the mud, and it is going to evaporate into a gas. So it's going to contract, it's going to pull away, it's going to get smaller and more compressed. So when that happens, it's going to pull away from that space. This area here once looked like this, but then as it dries, it will pull away, and you'll get a crappy little corner like this that's hard to shove mud into, and it's going to be very frustrating. So if you work slow, your corner will stay tight. Just do it. When you get to this point, start working really slow, put the mud ins a bit at a time, and you can go off and work on another part of your building, but then come back to this and add it in slowly, and your corner will stay tight. And that would be good for heat retention and cold retention. What's lovely about Cob and Adobe is that you can do little improvisations you could never do with a standard frame building. I've built many 16 on center frame buildings as well, and they're very unimaginative structures. You're basically building a house out of a roof. That's what a standard 16 on center, where 2x6 or 2x10 frame building is. You're just building a roof as the walls, and then you're putting the same thing on top. And so you can't use poetic materials, you can't use beautiful materials into the wall very easily. So with Cob you can. And so one thing I did is, there was a beautiful flat stone that I had found while I was out walking, and it had this wedged edge like that. And so while I was building, I just put a board underneath this to hold it up, like a piece of 2x4. Actually, I don't think I even did that. I think I set this stone, yes, I set this stone on top of the Cob wall, and I put a really heavy rock on top of it to keep it there, and I slowly built up the Cob around it, and this stone will not be coming out. You cannot pull it out because it has that wedge in it, and all this wall is holding it in, and that's the stone where I put my coffee pot every day. So that was very nice. So just to demonstrate, when you're working with this trough, you're building up batch one. Batch one, like I said, will make about 4 inches tall, and it'll go about 2 feet. You have batch two, and it'll go an extra 2 feet. Batch three, 2 feet. So this is essentially how you're building this. You're making these long, kind of 4x2, essentially 2 Adobe bricks at a time, basically. A little longer than that, actually, because a standard Adobe brick is 14 inches long. So you're making something that ends up being a little smaller than 2 Adobe bricks, but it's thicker. So you've got a thickness of 12, and you've got a length of 24 inches. So that's pretty good, So that is the rectangle you're making, essentially, in the wall. But it's a circular wall, so you don't feel that as much. But this is just to give you an idea of how much you're getting done at a time. I can't exactly remember how many batches I would make a day. Sometimes I only had time to make 4. Sometimes I only had time to make 12. It just really depended on the day and what other things I had to do. And I had to do this as I was building up the wall. I couldn't go back later and then put these in later. You have to do it as you go. Think of it like a 3D printer. It does everything all at once monolithically as you go. Now in these shelves, which is nice because cob is such a flexible material, in these thermal fins, these heat banks, if you will, I inserted shelves on the side, a little shelf here, and did that very simply by just taking 2 pieces of wood I wanted to use. I put a brick in between them as a spacer. I put the little nails on the ends, and then when it had set, I pulled the supports out and the shelves were suspended there. So that worked very well. As you go along in your building, you always want to be using your 4-foot level, checking for plumb. All plumb means, it comes from Latin pluma. Plumba means lead. I would take a lead weight and tie it to the end of a string and hold it out, and the gravity would grab onto the lead and it would make the string straight. It would tell you which way gravity is going. And you want your wall lining up with gravity, right? So gravity isn't going to shove your wall over, it's going to drive it into its own foundation, which is what you want. So this is unacceptable. That's not good. This is acceptable. Listen to your level. You'll know you're using your level the right way because often during the time of the day when it's the hottest and you maybe haven't drank enough water, you will start referring to your 4-foot level as your buddy. You'll start talking to your level and commiserating with your level, maybe complimenting the level on how it looks that day. That's how you know you're using your level right. It's going to become your little buddy. So this is the previous photo I'd shown you. This is my doorway, framed up, supported, braced, right? Need to do that. Now, after 10 days of this mud ceremony I just described to you, 10 days of doing this, this is what it looks like. So this construction, you see, that took 10 days. Now you'll notice here, there are these tabs of metal. That's called blood lath. There's a reason I'm putting those there. It's very important, and I'll explain why. Now, as before, this is my south side of the window, right? South window, south-facing window to let light in to create heat and illumination. Well, after 10 days of mud ceremony, that's what that looks like. So I'm about halfway up the south window at that point. This is me working with no power tools. I set up a little station here. I've got my water. I've got my bucket for sand and earth. I've got my mixing trough. I obviously took the photo. I'm not in this photo. But this is all being done with the human body. That's it. No power tools. Okay. Other things like my dead men, so that we're going to talk about that, how to anchor the roof into the walls. I'm putting in little niches for a reason. I'm putting in little niches here. I'm putting in little windows that I think are beautiful, that I want to be part of the structure. I'm putting in my shelves. I'm building frame outs for them. So I know that this is a milk crate, basically, that I like the dimensions of that milk crate. I wanted to use that as my shelf dimension. So there you go. I'm using that, using rocks to hold things down. And here's the track. Once again, I'm just laying the mud on the tracks. And there are the pieces of diamond lath that we will talk about that are really important. So this little view window, if you want to do something like that, and you see all this in the hand sculpted house book I mentioned. It's a wonderful book. You're building up the cob as you go until eventually the cob starts sitting on itself and it makes a circular window. And when this glass breaks or if it ever gets destroyed, I'm just going to dig it out and then reshape it. Not a big deal. What you're seeing here is my setup for my kitchen area. So I've got my shelves there. I've set my countertops over them. I've got my window frame you see there framed with a support. I've got my brace on the corner to keep it nice and square, nice and plumb. And to the left you see these, I called them latia shelves, which were free-floating shelves that I made by really just taking a board and screwing pieces of latia underneath, just driving the screw down, using those bricks as you see for supports. And it made a very nice cantilevered, free-floating shelf that was held by the mud. And here's a little detail on the latia shelf where I would just take a 2x8 board and I would screw the latias in, and it didn't matter if they were bent or crooked. If they were, hey, even better, because that would grab more surface area in the mud. And then I would put the porcupine nails in them and would hold them down in the mud with stones, with rocks to hold the cantilever, and just build up the mud around them, making sure they stayed level as I built. So what you're seeing here was done intentionally, and you are seeing the opening, a Roman arch opening into the north. Now you might be asking, why the heck would you put a window into the north of the wall? That makes no sense. That's where all the heat's going to be lost. Well, this is not a window. It's not a Roman arch window. It's built very similar to a Roman arch window, but what it is a refrigerator that needs no electricity. It is what is called a mass cooler. It has a sandstone slab on the bottom, which is what you see below that can. And the way I achieved this shape was I built up the mud around it above that sandstone with a frame. And I put that shelf, the first shelf you see, in there. And then on top of that, I placed a form that I built from flexible metal that formed that arch shape and held what are called straw corbels or cob mud corbels. And I built those up into the shape of the Roman arch, which will hold that structure. And I can get into the details of this. I left this in such a way that if this mass cooler didn't work, that I could just simply fill it in with mud later and be done with it. And I'm very glad I haven't filled it in, and it works very well. It's excellent as a cooling device in the summer. You open this up and you vent all the hot air out of your space. It works very well for that. And it works very well to keep food that you would want to have that you would refrigerate. I usually in the summer could keep yogurt. And I did tests on this. I wanted to see, how long will it go till it spoils. And I kept yogurt in this mass cooler using hand towels that I wetted. You just spray it with, I just used a sports bottle with a pop top that you can squeeze, like a squeeze sports bottle. And I would wet it from that. And I could keep yogurt in that mass cooler for 10 days before it would get a little weird. I would keep milk for 7 days with just a wet cloth sitting on that cold sandstone in the cold part of the wall. And the fruit actually in vegetables keeps longer in that mass cooler than a conventional refrigerator because it's never getting moldy. The air is always keeping things somewhat dry. So it was very effective, and I wouldn't trade it for anything. What you're seeing here is a detail of how I used a milk crate as a spacer in those shelves. I had a milk crate that just happened to have inch dimensions that I liked a lot. I was planning on using those inch dimensions anyway, and I would set the milk crate there, and when I was putting the shelving in, I would just make sure everything was level. I porcupined the edges, built up the mud around it, and it created a very nice aesthetic. I did a thing called straw corbeling. So what that means is you make the mud the normal way you would do it, but the straw, you don't mix it into the mud. You bundle it together like this, like in a handful, if you will, with all the strands going the same way. And then you dip it in the mud and let the mud grab onto it until it makes, and you want them to be about 12 inches because that's the width of my wall. I was very specific about that. It's real simple for me to measure 12 inches. I just took my spacer that I had that's 12 inches and I laid it up against the straw, and I made straw corbels, straw mud corbels. I
probably made a dozen of them or so, however many I needed to fill that space. So I had my 2x6 board, I had my flexible steel bent at the edges, I bent it on itself and I attached it to the board with screws. I had these bricks laid inside for support, and then I just set up the mud straw corbels on top until they went down into the mud. So these corbels, this is a cross section, if you will. They're being laid on top to make what's called a Roman arch, which is very strong, right? Sort of a catenary arch in a way, and it will hold a lot of weight. So that way I didn't have to put a lintel in here. The Roman arch will do its own supporting for that gap. And so that is how I created this. I set my support in there, and there you go, in addition to these shelves here. Now this mass cooler, what you end up doing is you have your sandstone here, and then I can put my eggs, my yogurt, my jars of stew, my juice. This tin for cheese thing, I've abandoned that now. What I use are just cloth bags for cheese, or I wrap it in a plastic thing. I find mice don't get in here because you're not advertising the scent very much. Then you can put your bread up here, whatever you want to do. But what happens is you're setting up this, on the exterior, you're laying down a layer of 1/4-inch hardware cloth into the mud around it. That 1/4-inch hardware cloth, a rodent cannot get through that. They can't shove their head through it. They can't bite through it. And you also lay on the outside of the 1/4-inch hardware cloth a layer of insect screen, so insects can't get in there. So you have open air, and the airflow will keep that food fresh. It keeps it from getting fungal infected, where it's just moldy. And in the winter, of course, you don't have to apply any water whatsoever for this mass cooler to work. You just let the outside temperatures cool it down. And because of the heat inside the wall, it is going to balance out that space. So you will not have things like yogurt freeze, even on really cold nights. That sounds weird, but it basically kind of buffers it and makes like a 40-degree heated space. So it's not going to be very, very cold in there. And it works. I used this for a long time. I still use it. And I don't have a refrigerator in that space, which allows you to live without conventional electricity. So we're continuing the build. We get up to the point where we start using these wires. What the heck are these wires sticking out? Are all these wires, right? Well, these wires are what are called dead men, and this is what's going to anchor my rafters of the roof to the building. So in a typical Adobe roof connection, roofs are made of wood. They're not made of Adobe. So they are two separate materials, and you've got to connect them. And so what happens is in the Adobe structure, you've got a concrete bond beam. Then you have to make a top plate with a J-bolt. And then you have a hurricane tie, and you attach that to the top plate to hook to the rafter. And that is typically how it's done. These concrete bond beams are expensive. They can cost you between $2,000 and $4,000 to make one. It's a lot of extra concrete to compress all of these separate mortared blocks together. Well, in a Cob roof connection, it's much simpler. You've already done your work of connecting the wall. You don't need a bond beam. And what you're going to do is you're going to get pieces of like oak firewood, or you could use Siberian elm. They sometimes call it Chinese elm. And you're going to stud that with nails, and then wrap number 9 galvanized wire around it. And then you're going to kind of, DNA double helix it up. And you lay this 2 feet, about 24 inches, down into the Cob wall from where the rafters are going to be, which you should know that distance because you're going to have an idea of how tall your rafters are going to sync up with your wall. And then you're going to wrap that wire. Once you get to that point where now you've got this wire sticking out, you're going to wrap it twice around each rafter, and you're going to hammer in fencing staples into the rafter to hold that connection. And that is not going anywhere.
A hurricane, a high wind event would have to literally rip 3 tons of earth up off the ground to make that happen. That is not going to happen. So it's very stable to hold your roof on. So just a little detail, like I said, you're going to wrap this around your dead man, and you're going to attach it with 1.5-inch fencing staples, hammer them in, and you're going to use number 9 galvanized fencing wire, which you can buy at Tractor Supply or a hardware store. So at this point, after 36 days of mud ceremony, this here is where we end up. So I have all the rough mudding completed from the foundation, the stem wall up, and it's ready to receive my viga. You would probably not need to use a viga if you didn't want to. And keep in mind, if you're looking at this structure thus far and you say, man, this is way too small for me, well, all you have to do is lengthen the diameter of your circle. This could easily have been a 20-foot wide diameter, wouldn't have been a problem. Could have been 18 feet wide, could have been 15. So you just adjust the size of the circle, obviously. But going back to this viga, the viga, that was a recommendation from a friend of mine who is an architect, who has also been a builder for 32 years. And he thought that would handle the very significant snow loads that Taos, New Mexico can get at times. So I opted for the viga. And you look at that viga weighs 530 pounds. That's very heavy. How the heck did we get that viga on there? Well, let me explain that to you. So you can see the viga is setting up there, and you can see the dead men in the background. So let me explain how we got that viga there. I did say that we did this, I did this structure without any power tools, no electricity on site. I was not kidding. So I had 2 friends of mine show up to help me. We got the viga off the delivery truck and with literally a piece of firewood. We just put the firewood on the ground in front of the viga. We all picked up the viga, set it on the firewood roller, and we rolled this sucker down the hill. It went very quick, very easy to get it in that position. Once we got it to that position, here's what we did next. A friend of mine brought a 4-foot ladder, and we got that ladder set up, and we picked up the viga, the 3 of us, and got it on the ladder at about the proportion you see right here, so that we had the back maybe quarter of the viga on the upper part of the ladder. So then, making a seesaw, the 2 of us got on that minority part of the viga and created a fulcrum and lifted the front of that viga up on top of where it needed to go. The other friend of mine, the 3rd guy, he held it there while the other 2 of us switched our body position while that ladder was helping us out, and we pressed that sucker over our heads and walked it and rolled it onto the top of the Hogan, and the viga went in place, no problem. Just had help of 2 friends of mine, 3 guys total. One of them was very knowledgeable about vigas. He had worked with his father delivering vigas and latias when he was a teenager in his early 20s, so he knew a lot of what to do. But that's how you do it. Roll it into place with a piece of firewood that's free of knots. It's very smooth. Get yourself a 4-foot ladder, stack that viga on it, make your fulcrum, and it will do what physics tells it to do. So let's talk about roof. I got a lot of controversy about this from friends of mine. What they wanted me to do was build this Hogan the way solar buildings are traditionally built, with a north-facing roof. So there are advantages to that because it exposes you to more solar gain on this side of the building. However, if you live in a place with a lot of snow, which I do, you have to know that your snow will not melt in the winter. People will tell you that's not true. they're probably not telling you the truth. For whatever delusional reason, they're telling you something that they want to hear. It's not true. I've lived in a structure with a north-facing roof for over 9 years before I built this Hogan. The snow is up there all the time, and the ice will dam the gutter, and you will not be able to catch snow water for your rain catchment. It will not happen. If anybody tells you otherwise, check their background. They probably don't know what they're talking about. Now, what I did was a south-facing roof, and people told me not to do this until I talked to people who are professional rain catchment advisors and builders, and this is the way they recommended to do it. This is the way earthships do it in the early days. And what ends up happening for the south-facing roof is it blocks intense summer heat, which you want. Your snow melts in the winter sun, and you have no ice damming on your gutter whatsoever. And once you put that gutter up, it will never come down. So I would highly recommend south-facing roof if you're going to do rain catchment. If you're not, do what you want. But this is the way to do it with rain catchment involved, which I was going to do with this Hogan. And there it is. The Viga is set up. I started planning where I would set my first rafter, getting an idea of the spacing as I went. And let me say one more thing about the roof and the summer sun. You have to forgive me. This is the first time I've done a PowerPoint like this. I'm eating breakfast this morning. Maybe my thoughts escape me here a little, but one more detail. I had mentioned earlier in the PowerPoint how this building performs very well in the summer because it is blocking that intense summer heat. I've lived in another structure that put the roof the opposite way, so it got as much solar gain as possible. And that building, okay, this building I mentioned earlier, it seldom ever got above 75 degrees in there. It would feel like sometimes like 67 degrees when you walked in there. That straw bale I lived in that had a north-facing roof, so it's getting all that solar gain, often I would come into that straw bale and it would be 88 degrees in there, if not 89 degrees in there. And I just put it this way, like this Hogan with this roof orientation, it passed the dog test. When I came home to that straw bale, my dogs would be in their crates and they would be panting from the heat. When I come into this Hogan, I let them out. They are never panting. They are very comfortable, as was I. Is use plumber's tape. And I would set my plumber's tape 8 inches into the cob wall. I would wrap it up over the Viga, use 2.5-inch star head GRK screws, or Gurks as they're called, and just wrap this plumber's tape over and screw it into the Viga, and you're good. That Viga is not going to move. They do this trick all the time with Viga construction now in Earth Homes, Adobe homes in New Mexico. Okay, so let's talk about this detail with lintels. So this is very common. People will build lintels and they don't put a 1-inch gap in. You have to do that. If you do not do that, if you leave no gap and you just set your lintel right on top of the door, you're going to have cracking on the corners that will not ever be able to be fixed as the cob settles and it dries, because it's going to contract around that and it's not going to have room for expansion. You need an expansion joint. You need a 1-inch gap in between so there won't be cracking. I did my 1-inch gap. I have no cracking at the edges of my lintels. Here's how you do that. To create that 1-inch gap, when you set your door buck in, before you put your lintel in, you're going to put 1-inch pieces of foam insulation. That's all I did. I just took foam insulation. I cut them maybe 4 inches wide. It's 1 inch thick already, and I made them 12 inches long so they laid on top of the door buck. The lintel extends at least 12 inches beyond the buck. You need to do that. Okay, so my lintel, which is going to be taking the pressure of the building where there's nothing to support the roof or the building here in this gap. Porcupine the whole thing. I used a 6 by 6 inch post to do that, and then I joined it with another 6 by 6 inch post, so it made 12 inches wide. And I'll explain that detail also.
So you have to join these two lintels together that are 6 by 6 inches. It seems a little complex. It's very intuitive though. It's real simple. Basically, you're going to drill 2 inches in to the first lintel with a 3/4 inch bit to establish this cavity. Then you're going to drill with a 3/8 inch bit into it all the way through the lintel, the post that will be your lintel, until you just tap the second lintel. You're just tapping this right here. Then you're going to drill with a 5/16 inch bit into the lintel a couple inches in. Okay. Then you're going to drive in this 3/8 inch lag bolt with a washer attached. So you're going to use a socket wrench, and then that lag bolt will push in here. And I think this lag bolt I used was probably an 8-inch. I think it was an 8-inch lag bolt because it went 6 inches through and then it went 2 inches into the next thing. And then as it's going in, as it's driving itself in, the washer is going to grip this piece of wood and it's going to pull the two pieces of wood into each other. And the washer is going to be the backer. It's going to be the clamp. So the end result is the washer clamps the lintels together, and your nut, the head of the hex head of the lag bolt is going to sit inside the lintel. It's not going to be on the outside to catch you or hurt you. It's going to be in this little gap. So that was a very nice detail given to me by an architect in Taos named Mark Goldman, who's an award-winning architect. He's a Boston Architectural College graduate and a professional earth builder, and that's a very nice little detail there. So when you set the lintel, you've got your setup there, you've got your connections there, you want to porcupine the ends, and you've got your 1-inch gap with your insulation there. And they're 12 inches on either side of the door. That's a really important detail. So after I had my lintels set, I had to keep building my wall. I had scaffolding on the way, but in the meantime, I just used straw bales. I just set straw bales up in a pyramid. I put scrap wood as my step. I had a wooden pallet on top. I had my lumps of mud, and I would just keep building up. And once I got to the roof, that's when I really needed the scaffolding. So I did get scaffolding from a friend of mine who was a contractor. He loaned it to me. No big deal. I was very grateful for that. But I'd be using these straw bales with wood on top to get up in there and be building. So there you have the roof. I built a very simple shed roof that I will go into now. You need this first. Before you start building a roof, you have to have a roof layout, and you have to know exactly how long are your roof members going to be, where are they going to sit exactly. You're basically building a box that weighs over 500 pounds, and you're suspending it in the air on top of a house. So you need to have details of like, where is it going to sit? How is it going to connect? Is there going to be a parapet or not? I ended up going with no parapet. And I even had it down where I thought like, oh, maybe I'll do these little edges at the corner on the south side. I ended up not doing that because to build the gutter for that would be so annoying and so ineffective. So what I decided to do was to honor the Hogan. I wanted the edges back here to be cornered like that, but for the front I decided to leave them straight so it would be easier to use the plywood. It would be easier to use the high temp water ice barrier, and easier to flash it, easier to put the metal on, and easier to build the gutter. Okay, so you need something like this. I showed this to a professional builder friend of mine, and he said, that looks really good. Did you do that yourself? And I did that myself using a spacing ruler. So get a spacing ruler, architectural spacing ruler. They're like the little tripod looking things. They're triangular. Use that. I made a diagram of where my roof is going to sit. I should know at what height. I knew that at the height of the viga, it was going to be 90 inches off the level floor. So I set my building at that. I then knew also that
I was going to be at 102 inches above the 90 inches because that's 12 inches up because I made my roof 12 inches thick. It's 2 by 12 so I could get more insulation. I knew what this height was going to be. I knew the second rafter, the height, this height, this height. So you have to know those things so that you know you're on track. I knew I was setting my roof at a 1.6 on 12. Some people would say that's stupid, that's crazy. The standard building code says you have to use 4 on 12 for if you're going to have a metal roof. And I understand that. But for the amount of precipitation we get where I live, a 1 on 6 is fine. Let me explain the 1 on 6 on 12 for those of you who maybe don't know. What that means is that for every foot, 12 inches of distance or run, there will be a rise of 1.6 inches. So if you just imagine that triangle in your head, 12 inches, 1.6, 12 inches, 1.6. And that's where it lines up as you go. Okay. And I knew my feet of distance from the viga. And I knew I was going back 6 feet from the viga. That's where I was going to hit. And I knew I was going to hit my wall at 100 inches. Okay. So you got to know all these things. And it's really not hard. It's just, this is, middle school math to figure this out. So shouldn't be a problem. Also, the substances in the place will talk to you. You'll figure it out when you're there building it as well. So for setting up my roof, like I said, I used no power tools. I did not have a shop to fabricate this stuff. It was real simple. I just took 3 straw bales. I put plywood on top of those straw bales to create a level surface, and I laid 2 2x12 boards on top of that, and that created a really stable level surface to work with. Like I said, I knew basically how my roof was going to work. I had my mud wall. I wanted an 18-inch overhang. I knew I was going to tie it into my front lintel with a hurricane tie. It was going to lead back to my viga. To do this building, what I knew I was going to have to do was going to need to be improvised, because I was building this so people on the Navajo res where I grew up would be able to construct this building. And so I knew that most people wouldn't be able to get 2x12 boards that are also 16 feet long, which is what you would need, 15 feet 9 inches. So I talked to a friend of mine who is a professional builder and an architect, and he recommended gusseting 2x12 boards that are 8 feet long and joining them together in a plywood gusset. So basically, I got 3/4 inch plywood. I laid it on either side of the rafter. I laid in liquid nails. I attached with 1.5 inch screws, and that joined these 2 boards, these 2 2x12 by 8s, with my tail cut and my ridge cut at 15 feet 9 inches, which is what it needed to be. And you're making rafter cuts so that your roof is going to sit level with the drip of water. I'll show you what I mean by that. Okay, so this is the gusset basically. Once again, I've got my 2x12. I joined it together with 3/4 inch plywood so that I could have a strong, stable, roughly 16 feet long rafter. And the distance from here to there was 85.5 inches. I took these things after I built them on that little table I showed you and just picked them up and set them on here and ran them up the building by myself. Then once they touched the wall, I wrapped that number 9 galvanized wire twice around the rafter and fencing stapled it in. And so that is rafter prime. That's the first one, and this is the second one. And my friend Christopher Colombo came by and he took this picture of me. My other friend, Molly Neiman, who is also an architect, came by to look at the structure. She had a disposable camera and took this photo of me. Now this tarp is up here because I had been laying the tarp over the roof that was beginning because I did not want water getting into the adobe areas where the wires were. I felt like it was a bit too sensitive, and I wanted it to stay exactly where it was, so I put that tarp over. In between the rafters, I put really big stones to fill the gaps. I wanted to that's just, gap that I needed to put in there. And so I filled a lot of stones in there in between the rafters to just make up the space. So I had to use less adobe. Also, I wanted big overhangs. You want big overhangs when you create an adobe building. So I made a lookout rafter, which is where you have a rafter just hanging out in midair that's not not being supported necessarily by your structure. Now, fortunately for me, this lookout rafter here was being supported by the Viga, but I needed to have something out here to connect it. So I just created a typical 2x6 lookout. Basically, you cut a little wedge down here into this rafter, which I did with a Ryoba Japanese saw, which are amazing. Those Japanese hand saws, go get one. They're worth every penny. They're probably worth 3 times the amount of money you have to pay for them. And they will cut like a lightsaber right down in there, and they'll cut that bottom out. You can chisel it out as well, and then you just use your typical GRK star-headed screws to attach to each other. And so after I blocked everything and after I built the lookout, there's a lookout rafter holding on here. There's my little lookout holding this out here out in space. I put those together. My roof plan was really basically simple, and you can use this too. It works very well. A professional builder in Taos, one of the best earthship builders in the world. He designed this for me, showed me how to do it. So I've got my Viga, and then I have my 2x12s. So this is if you're looking, up the roof, so to speak. Then I'm going to be putting R30 rock wool insulation in here with R15 rock wool insulation on top of it. Okay, so that I'm filling that gap. And then on top of that, I'm putting this, it's like a baffle, if you will, a rafter baffle to create an air channel. Then on top of that, I used 5/8 inch CDX plywood. I almost went with 1/2 inch. I'm glad I went with 5/8. Use 5/8, much sturdier. Then on top of that, I put a high temp water ice barrier, which is very important. And then I set a 26 gauge pro panel roof on top of that. So those are the layers of the lasagna, the roof lasagna, so to speak. Now, also before I set in after I'd set in the insulation, rather, I did put a 6mm vapor barrier at the bottom to seal all that in. So this. You notice this here. There's this lath there. What the heck is that doing there? The reason I did that was I was going to build something I'd never seen done before, but I talked to 2 professional adobe builders, one based in Wisconsin, the other one based in New Mexico, and I proposed this idea to them, and they said, that's really cool. I think that'll work. So what I did was I built a thermal wrap wall on the north side, and here's how I did it. I set diamond lath into the mud every 18 to 24 inches, depending on the structure and where things were, so that this way I would have about 20-inch long piece of lath. I would lay that into the wall. So this is 12 inches of wall. So then I had 8 inches of lath sticking out, and I just folded it up so it wouldn't grab me. They call it blood lath for a reason, because it cuts you all the time, draws blood. And then I knew this 8 inches of material would reach out and grab the second wall I was going to build back there. So I was going to build a double wall. So what you're seeing here is the layout that I used to create this shell wall. I had my diamond lath extending out from the wall. I left that 3-inch gap, and then I placed a 6-inch thick mud wall along from the edge of the door to the east running over to where I knew it would encapsulate near the window at the west, and it would trap in the heat that would be traveling into that wall, particularly from the spot where the wood stove would be located. The exterior of this wall does not get as protected as a result under the overhangs that I have. So I needed to coat it with lime plaster, which is a wonderful substance. So let's go into how to make good lime plaster. What you do is you dump the hydrated lime into the 5-gallon bucket, but you fill the 5-gallon bucket about halfway full of water first. You add this in and you stir it and you stir it and you stir it and you keep going. And what will eventually happen is you will create a putty that is the consistency of like shaving cream. And it will be hard to stir it with this board eventually. And you might need to keep adding water later. Usually you don't though. If you fill it halfway full of water and you keep dumping hydrated lime in with and you of course want to be wearing gloves, plastic, PVC coated gloves so you don't get it in your fingernails and then have your fingernails fall off. So you stir that and eventually it'll turn into a shaving cream, and then you will pour water in the last 2-3 inches of the bucket and leave it there to slake the lime putty. And you do that again for this bucket and you'll have enough lime plaster. And then you make it just like you would any kind of plaster. You use screen sand to make it very fine. Sometimes they sell plaster sand. You use plaster sand. And you just mix it with the putty and you mix in a little bit of straw. I think I use like I use a 1.5 to 1. So what that means is I would take 2 shovelfuls of lime putty and I would mix that with 4 shovelfuls of sand. Yeah, so it'd be 2 and 4. And then you mix that with straw and that's your putty. That's your plaster right there. You don't really add a lot of water. You might need to create more consistency, but that's roughly how I do it and it works really well. Okay, getting into the roof then. It's very helpful to know how your plywood's going to sit. I made a very simple diagram like this, basically understanding how my plywood was going to go up there. Now, you should be able to do this in your head. I'm dumb, so I have to do this on a piece of paper. But what's happening is your rafters coming in here. Then you need your fascia board. Sometimes they call that your rim joist, if you're a type of person who does rim joists. And that is going to bind the rafters all together. Think of it as the outside board of a box. And then you need an exterior board for your gutter though. So here's your plywood sitting up there. You've got your line of your plywood. What you need to do though is take a speed square to create the path of the plywood before you seat the plywood, because you need to make sure this exterior board for the gutter doesn't rise up into this area and tap where the plywood's going to be. It's got to be below the plywood. That's just a mistake some people make, because you have to preserve that line of the run of the water, because the water's got to come off the steel and land down in the gutter. So just some people put this up too high, and then you get there and then the water has nowhere to go. It can't go down into the gutter. So important detail. When you set up your plywood, just make sure you're doing your industry standard attachment. You got 8 nails on the edges. You want to use 8D ring shank nails. You set a line of nails. I use a chalk line. And you do 6 on the inner field. And you do 8 on the outer field of the plywood. And so it ends up looking like that. That's all my plywood up there. Ended up using the scaffold for that. Then we set high temp on. The high temp rolls on like a fruit roll-up. The reason I was able to do this so well is I have this young gentleman here, Christopher Colombo, good friend of mine, very good builder. He's a Navy veteran, just a wonderful soul. He came by and helped me out to do that. He has a lot of experience installing that. He's a professional builder.
And then you set your metal on top. We set the metal, set that up there. You'll find the best way to do that by talking to people who work with metal, work with Pro Panel. One detail you should know about Pro Panel is make sure when you lay your Pro Panel, you want to lay it in a way so that the prevailing winds and rain will not drive up into the metal, but rather they should ride over the metal. So the way we set this up, we set it up so that the first piece, which we set in the center, that it was going to have the curl run this way from west to east, because that's the way of the prevailing winds where I live. When you set up your Pro Panel, what we ended up doing was setting screws every 2 feet from bottom to top. We placed it on the ridges, not on the valleys. I've seen people do it different ways. I would rather put it on the ridge of the metal because gravity is less likely to push water into there. Whereas if you put screws into the valley running up and down, the water is just more likely going to sit there. Look, back here, I do not have any penetrations in my roof. That is how you're supposed to do it. People will tell you, oh, it's no big deal. You can put it right through the roof. Do not listen to them. They are wrong. It does not matter how carefully you flash that gap in your roof. I don't care how much silicone you put on there. I don't care how you cut the metal. I don't care what product the wood stove company tells you. Oh, no, that'll be fine. You know who's going to be there fixing your roof after it starts leaking? The wood stove company that told you to do that. Why do you think they told you to do that? Okay, if you can avoid going through your roof, don't go through your roof. In my case, I didn't have to go through my roof. I knew I was putting my wood stove up against the wall to throw the heat into the Cob Adobe wall, and so I took a 48-inch single wall 6-inch pipe as a chase, and I took a crowbar and a bucket of water and a scoop, and I dug a hole at a diagonal so that I knew my single wall could come up. It would make a 45-degree. This chase that I put in here would be able to hold a 48-inch single wall 6-inch pipe. The chase pipe I put in was an 8-inch pipe, so it had space. That way I don't have to re-dig this thing out if I need to change out the chimney pipe. And then I made a 45-degree pipe here and didn't have to go through my roof. So this is the basic outline of what I did, all the steps. Of course, you can pause the video and take notes on this. It works very well. I had a friend of mine build this steel bracket for me. It'll be different for you, however you want to attach it to the outside rafter. And that's basically what it looks like. Got my little envelope coming out here, my little chase pipe, boop, boop. This is actually a piece of plywood here. The steel bracket hadn't been built yet, but I just put a plywood mock-up there, knowing that my steel bracket was on the way. And then this pit you might be seeing here, this is the pit where I got my clay. And as you can see, no human dug these. This is from a backhoe. So I had a backhoe come out and dig where I was going to put my cistern. And that is, we dug this out on Halloween. So what you're seeing here is the door. I decided on a very simple door because every Hogan that I had looked at on the Navajo res near where I grew up had very simple doors sealed with a padlock from the outside. What you're seeing here is a Dutch door that I built using a product called an Easy Gate. I built the lower door out of that because it gives you a pocket, a very nice pocket between these steel brackets that you use to corner the door, so that you can fit insulation into the door between the outer 2x4s and the inner. I think I used a tongue and groove 1x6. So I had a kind of an insulated door, which is helpful for the thermal performance. And the door on top, because there's two doors, is what they call a Dutch door. I was also able to build it in a way that I made a pocket for insulation to sit inside the door. And this Dutch door works very well. Dutch doors are recommended on earth buildings, cob buildings. In fact, most cob buildings prior to World War II were a Dutch door because there was no air conditioning yet that was widely available. You get better flow of air using the Dutch door. So I saw that in the hand sculpted house book and thought it was a really neat idea. And it also gives the Hogan a way to air out the heat, which works very, very well in the summer and allows the building to breathe. And it's just a winning little detail that I really like. And those pieces of wood on the top door were just decorative. They were beautiful pieces of from boards that had been outside, probably sitting under the sun for 30 years, that I used from my friend Molly Neiman. And there's the door. And then I eventually sealed it with Thompson water seal and installed a really simple gate handle. And the padlock is there. I've lived with a building sealed with a padlock, not a latch, nothing fancy like that. Lived in a building like that for 9 years, and I really had no problem with it. So that's how the door was done. For the interior, like I said, I set my 6mm vapor barrier there. I built the ceiling in honor of the chief blanket. This is all rough sawn. Did it that way on the interior there. It's around Christmas time. That's why this gumdrop strand is there. And so here we are, back to the plans. This I had with me in a little notebook that I took to the site. Every day I packed it in the same bag that I had my lunch in for the day. And as you can see, I made modifications. So I brought the black ink one with me, and I made the revisions with blue ink so I could see the difference while I was building. Made little reminders to myself on this copy. So this is like the builder plan edition you're seeing here. I had some little changes I wanted to make. I had some little adjustments I thought of as I went, and some of them I didn't end up using. So it really was a matter of the space. But you can see in the center, you have the wood stove positioned there. You have the cob fins on either side, the window placement, and you see above it is the utility beam, and so that's what it looks like in the plans. And here is what it looks like in real life. So pretty similar. I got my fins there. I got my little pockets I made in the cob to store my matches and my kindling. Rolled up newspaper, plenty of room for boiling water for tea or coffee. You can see the utility beam located above, so I can hang my cooking ware, and it's all located in a very similar way. So from plan to real life. So this is what it looked like in the rough. I put these cans up here, these little coffee cans, and I embedded them in here about a third of the way, knowing I could put kitchen implements in them. And so this is what it looked like when I was building it, and that's what it looks like now. So I just plastered over them. I set my implements there. I have my propane stove. I can pretty much cook anything I want in here that you would on a conventional stove. My water, my towel. I bathe in here. And this wonderful solar lantern made by Bare Bones, called Bare Bones Solar Lantern. That's the railroad lantern. That thing is awesome. It has a really nice lithium battery in it that runs off my solar panel. This was what it looked like roughly when I had my space for my mass cooler, my shelves, and this is what it looks like now. So I've got my books there. I hang up this blanket here
so that it will cover the door, which is also insulated, and protect it from being too cold in there. And I've got my shelves. All my food is put in a way so mice cannot get into it. And there's my bedding. That's my mattress, heavy-duty sleeping bag, comforter. It all works very well. Very good writer, by the way. Very good thinker. You should check him out. This all happened in many ways due to this man. I keep a coffee mug in the space for him. That's his coffee mug there. Mark Goldman. That's his registered. Contact that guy if you like what you saw. Then I just did the floor. Now the floor, I decided to do brick on sand because I think it's very beautiful and it's easily maintained and easily fixed. So I dug out the floor with the mattock, being very careful. I brought the sand in, tamped it. Basically, I set these little pins. I think I used, I forget what you call them. They're basically like long screws. I'm having trouble remembering what they're called. But you can use anything, any kind of spike that's like 6 inches long or 4 inches long, 5 inches long. It needs to be 3.5 inches though, because I know that my sand's going to be 1 inch, my brick is going to be 2.5 inches tall, and I use those to level everything. And I kept it really simple. You know, I just got my 4-foot level. I would level the pins 3.5 inches up with a tape, making sure everything was correct. And then I set my sand up, and then I set my floor up. And so that's what it looks like now. I ended up doing the rest of this as an Adobe floor, which was very nice. And that worked very well. Now, going back outside to this lath, like I was saying about this thermal wall, I did build it, and that's the 6-inch thick wall coming up. You can see the perlite sitting inside there like that. This was the diamond lath, like I'd showed you before. The mud shell would go over it. It was like a shell wall or a thermal wall. That's what it looks like there. And that's what it looks like a little closer in, so you can see the cob wall. It's grabbing that lath and connecting to this wall, and you have the 3-inch gap being filled in with perlite. And so here we are. That's where we ended up. There's the finished shell wall covered in lime plaster. I ended up adding this shell wall the following summer because, of course, you can only build Adobe in the summer. You don't want to do that in the winter because the ice will form. It will spall the wall and break it apart. That's what it looks like from the side. I ended up inserting these little chases and these sticks for hanging laundry because I know the western sun is the most intense and it will be the last light of the day, which is typically when you want to hang, when I end up hanging my laundry because I'm, dumb and I forget to put it out there at the right time. But I know I have some light at least in the west there. Also, you'll notice a little detailing on the roof here. Done with metal, flashed that. I did all that with rivets, also known as rivets. We would affectionately call them ribbets, with a rivet gun. And you can get those, of course, at a hardware store, and they're very handy and very easy to use. They're wonderful. Rivets are great. And then my steel bracket came in. So there we go. My buddy made it for me and ran it down in there. And it was looking like this by Halloween. And there's my little jack-o'-lantern sitting out there. And my solar panel out here, it's a 100-watt panel. It's running into a power box inside that powers and charges everything off of a 12-volt lithium iron battery from Life Pod. And it works very well. And there's the door. It has, I think at this point, the door has been weathered, and I ended up treating it with Thompson's water seal. I made these little crickets and little metal sheathings for the exterior viga, and closed in all my soffits. I did open soffits. I basically just mudded around the 1/4-inch hardware cloth that I set up in the building. If I wanted to close these soffits, I could. I just don't feel like doing it right now because why waste the material? It's fine as it is. And that's what it looks like when you go into the door. Saluting the east. And so this was me taking you through this experience. I hope this information helps you. If you need to contact me or talk with me about this, you can leave a comment and I will try to reply to it. Thank you. Yeah. So the total cost was $3,400, and there was no electricity on site when I built this building. I took no loans. This is all hand to mouth. Thank you.